Hey everyone, so today we're going to do a review on transformations. So we're going to start with basic transformations, and I'm going to flip back and forth between the smartboard here and then these links that are from Desmos. You can also revisit the links yourself if you'd like to go back and look at them, but this should be a review for you. So this should be something that you already remember and know. So keep that in mind as we're going through, because I'm going to probably go through it a little kind of fast. So the first thing you want to recognize is that this right here is something that's causing two different types of transformations, so different types of shifts. One of them is horizontal and one of them is vertical. So we're going to take a quick peek at the Desmos link so you can see the difference between what H does and what K does. And I want you to notice that H is inside with the X and K is outside. So this would be with the Y. So you've got horizontal and then vertical. All right, so here we go. Let's go back to Desmos. So here's the first one. So notice, well, let me make some changes here. I'm going to make H be 0 and K be 0 so that you can see that when H and K are 0, this is the first function. It doesn't even matter what it is. It's just some function that we're doing f of x plus H plus K to it. So when H is 0 and K is 0, the functions are the same. When I take the H and I move it, so basically I make the H be positive, so this would be x plus 1, and then this would be like x plus 3. Okay, you can see that it's moving to the left. And then when I go to make the H's negative, so this would be like x minus 3, it's moving to the right. Okay, and then back to 0 here. When my K, I'm going to move the K now. So if I move the K, make the K be positive. So notice this would be like, let's get something nice here. So when K is 3, so it'd be a plus 3 out here, the graph moves up. And when I go to negative values here, so negative 3, this would be a minus 3. The graph, moves down. So we're going to use that information to write down what is happening here. So what effect does H have on the function? So if H is negative, so if it's like something like x minus 3 like we had, not writing well. So if H is negative, then the graph goes to the right. And if H is positive, so something like x plus 3, then the graph moves to the left. So this kind of does the opposite of what you might think it would do, okay? Let me get my pen a little smaller here. Okay, so now let's think about the K's. So if K is positive, okay, so positive, let's try that again. So if K is positive, it's going to kind of do what you think. The graph is going to move up. And if K is negative, then the graph is going to move down. Okay. All right, so we're going to do 3 practice problems with just horizontal and vertical translations. So these are called translations that we're doing here. So I'm going to do these transformations, here we are, with the defining points that you should have learned already. You do need to, when you're doing these types of graphs, be able to show me the original points and the transform points. You don't have to graph both, but you do have to show both. So this here has a horizontal translation. It's moving to the left. So it's moving to the left 3 because it's a positive 3. So this would then, each of these x values would move to the left. So this would be a negative 3. Then this becomes a negative 2. And this one is a positive 1. Okay. The y's are not moving at all, so the y values stay the same. So I have negative 3, 0, negative 2, 1, positive 1, 2. So there's my square root function. If you prefer, you can, and I know some of the honors algebra teachers do this, you can start with the original defining point. So 0, 0, 1, 1, 4, 2 like this. Graph it, and then graph the translation moved to the left. Okay, so that's totally fine, just as long as you can show the teacher who's grading your work which is the final answer. So there's the final answer. Okay, use the smaller pen here. So now let's do this cubed root function. So these are the 3 defining points for cubed root. This is now moving down. The y's do what you think. So it's going to move down 2. So the x's stay the same. So down to negative 3, down to, oops, that's not what I want. Down to negative 2, down to negative 1. Sorry, this is the first time I'm actually using this touchscreen for a video, and it's not as good as I would have thought. All right, so there's the first point, second point, third point. Graph it. That's the transformed graph. That's all you need to put on there. But again, you can put the original defining points and then do the shift on the graph if that makes you more comfortable. All right, this last one here is, excuse me, is a absolute value function, and it here has a horizontal and vertical transformation. We're going to go to the right 2 and up 1, to the right 2 and up 1. Okay, so that means if I go to the right 2, I have 1. To the right 2, it's a 2. To the right 2, it's a 3. Again, these are the original defining points. Up 1 goes to 2. Up 1 goes to 1. Up 1 goes to 2. So it's over at 1, 2, 2, 1, 3, 2. And there's your graph. Okay. The original would have been here. Okay. You have to somehow show us those points. That's really important. Especially because of this year where you're either doing it on a piece of paper that you're submitting or you're doing it on your touch screen, it's going to be hard to tell if the graph is correct or not. So you really need to make sure your points are listed on your paper. Okay, next we're going to talk about scaling functions. So this is when you have something happening on the outside multiplied or on the inside multiplied. Excuse me. So let me get my highlighter here. So this is kind of the general setup, and we're going to go ahead and look at the Desmos graphs that go along with these. Okay, so again, here's our original function that is in red, and then the orange function is scaled. And right now, if their A and the B are the same, then the graphs are the same. So if I change the A value, which is out front, so that is a vertical transformation there, it's happening to the Y's. If I make this A bigger, what's happening is the Y values are getting bigger. So as you can hopefully tell, right here, this would be 1 at this spot here. And this is the original graph's 1 value, and then original graph's Y value, excuse me, and then it's been stretched out. So it's been pulled up and pulled down, so that you would call this a vertical stretch when the number outside of the function is bigger than 1. And then when I make it less than 1, it would compress or shrink. So the Y values are getting smaller as the X values are staying in the same spot. So I'm actually going to go back and we'll write that down right now. So this is the value out front. So if your A is greater than 1, you have a vertical stretch. Okay, really just means that the y's are getting bigger. So you're going to multiply, well, that's not easy to read. You are going to multiply the y's by A. Okay, and if A is between 0 and 1, now we would call this a vertical. Depends on who you had, if they called it a compression or a shrink last year, I don't care. And you're still going to multiply the y's by A. It's just going to be a fraction that you're multiplying by, that's all. Okay, let's look at B now. This is usually where the issues happen. Okay, so let me put this A value back to 1. And now I'm going to move the B's, okay? So if I make a B bigger than 1, the x's should change and the y should stay the same. That's what we're looking at. So if x is bigger than 1, sorry, if b is bigger than 1, the x's are getting smaller. Do you see that? So the y's are staying the same and the x's are getting smaller. So although b is bigger than 1, the x values are getting smaller. They're compressing and getting closer to the y-axis. So you're getting smaller x values when that b is bigger than 1. And then the opposite will occur when I go less than 1. So as you move smaller here, well, it doesn't want me to go. There we are. So as you get less than 1, the x values actually get bigger and stretch out the graph. This tends to be an issue. I have a little phrase that I say y's are y's and x's are not. Y's do the thing that you think and the x's do the opposite. So let's write this down. So if B, didn't change my color. If B is bigger than 1, then this will be not a horizontal stretch, but a horizontal compression. And you won't be multiplying the x's by b, you will multiply the x's by 1 over b, because it has to get smaller. So since b is bigger, you have to multiply by the reciprocal. Now, if b is a fraction, so between 0 and 1, now you're going to have a horizontal stretch. That's when those x values spread out. And so you will have to still multiply the x's by 1 over b, but it's going to make it a whole number now, or it's going to make it a number bigger than 1. It's going to be the reciprocal. Okay, so let's practice these. So here's our first one. It is an absolute value graph. The number is out front of the function, so that is something happening to the y's, and the y's do exactly what they're supposed to do. So I'm going to multiply the y's and leave the x's alone. All of the y's are going to get multiplied by a fourth. So -1 a fourth, 0, 0, +1 a fourth. And I'm going to go by, well, I'm going to make this right here be 1, -1, 1, -1. That way I can see the value that I'm graphing. So this is -1. Oops, that is not. -1 a fourth, 0, 0, +1 a fourth. You are also absolutely allowed to change the window of your graph as long as you tell me and you mark it on your grid. Okay, this one here is a horizontal change. So this is changing the x's, which means you have to multiply by the reciprocal. So you're going to multiply all the x's by a half. So this is going to become a -1/2, -1, 0, 0, positive 1/2, 1. And let's go, this will be 1, negative 1, 1, negative 1. So I have negative 1/2, negative 1. Oops, that doesn't look so great. I didn't get that well. There we go. All right, try that again. So I have negative 1, negative 1/2, 1. Sorry, negative 1/2, negative 1, 0, 0, positive 1/2, 1. So I have the cubed root function that has been compressed. Okay, I have two transformations going on here. So I have to change both the x's and the y's at the same time. So I'm going to multiply the y's by 2, no problem. And I'm going to multiply the x's by 3. Okay, so this is going to become negative 3, positive 2, 0, 0, positive 3, positive 2. Okay, so it's a stretched out and stretched out both directions squared function. So negative 3, negative 2, 0, 0, positive 3, positive 2. And there you are. Okay, last thing we're going to talk about, I'm not going to show you this because I think you guys know this one, and I know this video is going a little longer than I wanted it to. So this is just about reflections. So I hope that you understand that when you have a negative out front of the function, the negative here will be a reflection over, so it's changing all of the y's, so it's a reflection over the x-axis. And if the negative is inside the parentheses, so attached to the x, it's changing all of the x values, so the x's go from positive to negative or negative to positive. So that means it's a reflection over the y-axis, or it's across, if you'd like to say it like that. Okay, if you do both x and y, so this is both a reflection over the x and over the y, you know what I'm going to do? I'm going to have you guys figure this out yourself and tell me during class tomorrow. Or tell your teacher during class. So I want to see if you can figure it out yourself. Okay? Something to be discovered on your own. Okay. So the first one here that we have is the square root of negative x. So all of the x values are becoming the opposite of what they were. So 0, 0, negative 1, 1, and negative 4, 2. Again, it's a reflection over the y-axis because all of the x's are changing. So 0, 0, negative 1, 1, 1, 2, 3, 4, negative 4, 2. Okay, so there is kind of a bad graph. This is the graph of 1 over x. The negative is technically out front of the function there, but something special happens with this one, and if you know what it is, you could also share that in class tomorrow. So negative is out front, so it's like changing the y's. Okay, so that makes this be 1, negative 1, and negative 1, negative 1. Well, that's not so great because those original points are wrong. So let me erase these and whoops. Okay, so the original graph of 1 over x, maybe this is a good time to actually draw the original, has defining points of 1, 1, negative 1, negative 1. So let's cross this one off. And then the graph goes something like this. This is the original. But we want to change it by making all the y's the opposite of what they were. This is why there was a problem, because I was not getting the right graph. So this point now becomes 1, negative 1, negative 1, positive 1. So my new graph is 1, negative 1, -1, +1. So the red is the new, and the black graph is the original. Okay. All right, so I'm going to go ahead and do this. I'm going to graph it, and then maybe this will help guide you on what your answer would be for up above. So here's my defining point for my absolute value function, and I've got changing the x to negative, changing the y to negative, or changing them to be the opposite. So this becomes +1, -1. This stays at 0, 0, and this becomes -1, -1. Okay, so that is the new graph on that one. And maybe you'll be able to tell me why tomorrow in class as well. And you might want to experiment with, let's say, this as well. So what will this do when you're going to graph that? All right, that was a little longer than I wanted it to be. Hopefully you can speed your way through it and maybe put my voice at 1.5 times. But otherwise, we will see you tomorrow.